In 9.93, we're still talking about hypothesis testing for two populations, and this time we're going to talk about means instead of proportions. Okay, so most of it's going to be the same. Again, we'll have some new symbols, and we'll talk about how to put it on in your calculator. Okay. So, we've got women's pulse rate. So the claim is women's pulse rates are higher than men's. Okay. So what are our two populations? Well, we have men, which we'll call population 1, and we've got women, which we'll call population 2. Now, symbols, we know for mean, for population mean, we use mu. So for population 1, we're going to have mu1, and for population 2, we'll have mu2. The size of the sample is always n, so n1 and n2. The sample mean is always x bar, so we'll have x bar 1 and x bar 2. Our sample standard deviation is always s, so we have s1 and s2. Okay, so here when we're talking about means, their average pulse rate, mu1 will be men and mu2 will be women. So our null hypothesis would be that they're equal, that the pulse rate of men is equal to women. Now our claim is that women is higher, so mu1 is less than mu2. Okay, so we're going to test this with alpha as 1% or alpha is 0.01. Now to do this, we're going to put the men's pulse rates that we have here in L1. Okay, so remember stat edit. And then the women's in L2. So what we want to know are these pretty much the same, or are women's pulse rates significantly higher? Okay. Now, both of them are small, but since pulse rates are normally distributed, that's okay. So we put the men's into L1 and the women into L2. And so now to get to the hypothesis testing for two means, you're going to hit stat, go over to tests, and choose number 4, sample t-test. Okay, and we're going to put data in. So in list 1, you should put L1 because that was population 1 is the men, and we put those in L1. And in L2, list 2, you'll put L2. Okay, frequency, you just want 1 and 1. And remember, our claim was that mu1 is less than mu2. So we choose this middle one. Okay, and then we're always going to choose no for pooled. Pooled, we only use if we know the two standard deviations are equal, which most of the time we'll have no idea. Okay, you'll scroll down and hit calculate. And it's going to give you t is equal to negative 0.812. And P is 0.215. Okay, now remember our alpha was 0.01, so P here is bigger than alpha. So remember, if P is bigger than alpha, we have not rejected the null hypothesis. Now, our claim was the alternate hypothesis, and when we do not reject the null hypothesis, we do not support our alternate hypothesis. So we would say we do not support the claim that women's pulse rates are higher than men's. Okay, so the next one says, a company conducted a contest for promotion. Some of the employees who were not promoted filed a lawsuit claiming that the competition involved discrimination based on age. So our claim that we're going to test is the employees who were not promoted were older than those who were. Okay, and we have two populations here. One will be the employees who were promoted, or we'll let one be who were not promoted. and then 2, the employees who were promoted. Okay, now our claim is that the ones who were not promoted, which will be at mu1, were older than the ones who were. So our alternate hypothesis is that mu1 is greater than mu2, and of course then our null hypothesis is mu1 equals mu2. Okay, and we're going to let alpha be 0.05. So here's our study results. So for non-promoted employees, that's our sample, our 1. We have a sample size of 23, so that's going to be our N1. Our average age, so our X bar 1 is 47. And our standard deviation, that's SX1, will be 7.2. And the ones who were promoted, we had 30 of them, so our N2 is 30. Their mean age was 42.5, so that's our X bar 2. And their standard deviation was 5.9. Okay, so you're going to put all of that in your calculator. You'll go to the same place as you did before. Okay, and then remember our claim was that mu1 is greater than mu2, so we'll choose that one. We don't want it pooled. If you do this, your t is going to be 2.44, and our p-value is 0.0096. So remember our alpha was 0.05. So p is less than alpha. So when p is less than alpha, we reject the null hypothesis, which means we can support the claim. So we'd say we support the claim that employees who were not promoted were older than those who were.